Isaac Newton over here did a lot of interesting stuff. He's also a handsome dude, as you can see. One of which is describing Newtonian mechanics. He also invented calculus simultaneously along with Leibniz. Leibniz's notation's better, but it's fine. The principles work well for describing this, and that's why using calculus to study physics is useful, because it was developed to try and describe the physical phenomena that we're going to be learning about. And his descriptions of how physics works here in this mechanical regime works well for most things, as long as you're not traveling close to the speed of light, and as long as you're bigger than tiny molecules. Newtonian mechanics is a really useful model for how things behave. So his three laws are basically inertia. So this is the first law, which is that a body at rest remains at rest, or a body in motion remains in motion unless acted on by a net external force. In other words, things don't just start moving or stop moving by themselves. It's because something acts on them. And this seems maybe obvious to you today, but codifying this gives us some tools to describe mechanics. The second law is F equals ma, or the sums of the forces acting on something are equal to the mass of that thing times the acceleration that that thing experiences. We'll go into that in more detail. And then the third law is for every action, there's an equal and opposite reaction, or whenever one body exerts a force on a second body, the first body experiences a force that is equal in magnitude and opposite in direction to the force that it exerts. So those are Newton's three laws of mechanics, and seem pretty simple laid out like this, but they give us a lot of powerful tools for describing motion. Let's look at the first law a little bit more. This is the law of inertia. We said things don't just start moving by themselves. The velocity of an object doesn't change unless something makes it change. To describe this, it's useful to have a concept of an inertial reference frame, which is a reference frame in which this law is valid. You might think, wait, when would this not be valid? When would something just start moving by itself? Well, think about if you're in a car and it's braking. That's a non-inertial reference frame because the car is accelerating. So my reference frame, as I sit there, it seems like I'm just being thrown forward because I'm in a non-inertial reference frame. So you can get these pseudo forces in non-inertial reference frames. So as long as you're in a non-accelerating reference frame, or a reference frame that's moving at a constant velocity relative to some other inertial reference frame that it also has to be inertial, then Newton's first law is valid. So anything that's accelerating, this includes rotation, is not an inertial reference frame. And you can see some behavior if you just try and analyze it in there that seems like things start moving without some actual net external force acting on them. That's Newton's first law.